Properties of Z transform. First property is linearity property. The Z transform of the signal x of n is x of z, and x1 of n is x1 of z, and x2 of n is x2 of z. Then what is the linear combination of the signal? Okay, the linear combination of the signal 1 and 2 is ax1n plus bx2n, and the corresponding Fourier transform, corresponding Z transform is A x1z plus B x2z. Okay, prove Z transform of the signal x of n is equal to summation n minus infinity to plus infinite x of n z power minus n. Then what is the Z transform of the linear combination of the signal, that is ax1n plus bx2n? Okay, so that linear combination is a transform of ax1n plus bx2n is equal to summation n minus infinity to plus infinite ax1n plus bx2n multiplied with z power minus n. Okay, so now I can split these two terms. The summation n minus infinity to plus infinite ax1n z power minus n plus summation n minus infinity to plus infinite b x2n z power minus n. So a is a constant that we can take outside. That means a is a transform of x1 of n. Similarly, b I can take outside. B is a transform of the signal x to n. That is a x1z plus b x2z. The next property is time shifting property. X of n is the signal, the Z transform is x of z. Suppose the signal is shifted by the amount of n, okay, by the amount of m, say for example right side here, then what is the Z transform? That is z power minus m x of z. Proof. Z transform of x of n is equal to summation n minus infinity to plus infinite xn z power minus n. And what is the Z transform of this signal, shifted signal? That is Z transform of x of n minus m is equal to summation n minus infinite to plus infinite x of n minus m z power minus n. Now we can replace n minus m with a new variable, and say for example, let us take n minus m is equal to lambda. Then what is n? N is equal to m plus lambda. Okay, so if that is the case, then we can modify this. Okay, so n is going from minus infinity to plus infinite, so that's why lambda, the new variable lambda also will go from minus infinity to plus infinite. Okay, x of n minus m I can replace with lambda. Okay, then z power n I can replace with m plus lambda, that is minus m plus lambda. Again from this we can take z power minus m outside. Okay, see, if we concentrate here, the summation is with respect to lambda, x of lambda, z power minus lambda. That means z power minus m is nowhere related with this summation, so we can take that z power minus m outside. Okay, so if we proceed further, z power minus m summation lambda minus infinite to plus infinite x of lambda is z power minus lambda. Okay, again if you see here, if you concentrate on this summation, Okay, everything is with respect to lambda. So, okay, so just now I can replace lambda with n. Okay, so replace lambda by n, then z power minus m, n minus infinity to plus infinite, x of n z power minus n. Okay, so this is z power minus m, is a transform of the signal x of n. Okay, so that is z power minus m x of z. Okay, so next property is multiplication by exponential sequence. Multiplication by exponential sequence. Okay, so that means x of n Fourier transform, sorry, z transform pair is x of z. Then what is a power n multiplied with x of n? Okay, so now we are multiplying the original signal x of n with the new exponential sequence, that is a power n. Okay, a could be anything. Okay, it is a number. Okay, again, it may also be like a e also. Okay, a may be e. Okay, so a value could be equal to e also. So then if that is the case, what is the corresponding z transform, that is x of z by a, x of z by a. So now proof is the transform of a power n x of n is equal to summation n minus infinite to plus infinite a power n x of n z power minus n minus infinite to plus infinite x of n. Okay, a power n, this is z power minus n. Okay, see here a power n multiplied with z power minus n, I can write like a power minus 1 z power n. Okay, a power minus 1 z power uh, something is wrong, a power n z power minus n. Okay, so this one we can write like a z inverse whole power n, z inverse whole power n, but we need minus n. Okay, with respect to formula we need minus n, so that we can write like a inverse z whole power minus n. So this a power n z power minus n we can write like a inverse z whole power minus n. Okay, so in the original formula in general, okay, so is a transform of x of n is equal to summation n minus infinity to plus infinite x of n z power minus n. So this we will write like x of z. Okay, whatever present here, that we will write here. Okay, so so similarly this one we can write like x of, instead of z it is multiplied with a inverse. So this is x of a inverse z. Okay, so this we can write like x of z by a. Okay, x of z by a. Next property is time reversal property. Time reversal. X of n is a transform pair is x of z, and x of minus n is a transform is x of z inverse. Okay, is a transform of x of n is equal to summation n minus infinity to plus infinite x of n z power minus n. Then what is the z transform of x of minus n summation n minus infinity to plus infinite x of minus n z power minus n. Okay, so now we can substitute minus n is equal to some new variable. Okay, that is p. Again, the summation varies. Uh, okay, summation varies from plus infinite to minus infinite. That means p varies from plus infinite to minus infinite. X of p x of p, z power n is equal to minus p. This we can again summation whether it goes from infinite to minus infinite or from minus infinite to plus infinite, both are same. So we can write like p goes from minus infinite to plus infinite. Okay, x of p z power minus p. Okay, so finally summation p minus infinite to plus infinite x of p z power minus p. Okay, so I think we have made a mistake here. Minus n is plus p, so here it will become like plus p. This is also plus p. Okay, plus p. Okay, so now this we can modify like summation p goes from minus infinite to plus infinite. X of p z inverse whole power minus p. Z inverse whole power minus p. Okay. Uh, Again, now we can replace with the variable n. That means n goes from minus infinite to plus infinite. X of n is z inverse whole power minus n. This we can write like x of z inverse. Okay, whatever present here, that we'll write here x of z inverse. Okay, thank you.